Today's lecture is a summary of what we saw and an opening into some more advanced topics in the field of process mining that we did not have the time to cover in this course naturally. I am always trying always to make sure that what we discuss in the lecture is practiced in the practice session and in the homeworks and in the project, and then is in the exam. And then that by doing that, I don't have the time to cover every single topic I would like to cover. But today I'm going to talk about these other topics that if we had more time, I will try to go deeper and work out with you, for example, using different Python libraries. So let me start with a recap of the course. So the starting point of process mining is a realization that over the past decades, organizations have structured their processes around some enterprise information systems like customer relationship management systems to manage everything related to customer contact and sales and leads and etc. Enterprise resource planning systems, ERP systems, to manage all their production and logistics, and in the case of companies that have to manufacture or ship products, etc. Supply chain management systems to manage all the purchasing relations with their suppliers, like a company like Selver, like Tallinna Kaubamaja, will be using a lot of supply management software to interact with their suppliers through electronic data interchange platforms, etc. Every company is using different types of systems that are recording audit trails about the execution of activities in different processes of the organization. The way these things are recorded is such that you will often find some identifiers of business processes, like a purchase order identifier acts as an identifier of a purchase order. A quote identifier acts as an identifier of a sales process. A patient ID or a loan application ID acts as an identifier of a loan application handling process. So these identifiers are there stored in the records in the database. Next to them, there are usually timestamps because organizations need to make sure that they have a historical trail of what happened then and what was done then. This is very necessary to do certain types of verifications. And third, there are names of activities or codes of activities very often that tells you what was done. And sometimes you have information about who did it and information about what was the state of, let's say, the loan or the purchase order at the time that this event occurred. You can take that information and then join it with tables about your customer data or your supplier's data and construct event logs in the form of big data frames that have a column for the identifier of a process instance of a case, a column for the timestamp, maybe sometimes multiple timestamps, so much better, and a column for the code or the name of the activity that was performed, the person who performed it, and lots of other attributes. And you can feed that into a process mining tool, and the process mining tool can derive different types of visualizations that give you different types of insights. One of them is the process model. And we saw that process mining tools can usually, a promoter is just a representative, but could have been Celonis, it could have been IBM process mining, or some other, or SAP process intelligence. These tools will give you different types of visualizations in the form, for example, of process maps. Process maps are very simple boxes and arrows things, and the boxes are whatever you want it to be. Could be a name of an activity. Every box represents an activity and is labeled with the name of the activity. Or it could be the name of a resource, of a worker. So every box is a worker, and the box is labeled with the identifier of that worker. Or it could be the status of the application, etc. Anything that changes over the life cycle of the process. Process maps are, very simple to construct, very fast to construct, and that's why it's the preferred visualization of process mining tools. But they do not separate between parallelism and choice and repetition. They kind of mix it up and leave it to you to figure out at which point you have a choice between two branches, or parallel forking between two branches, or a repetition of some one or more activities. By discovering BPMN models where there are explicit gateways with a particular semantics, execution semantics, you can get a finer grained view of that allows you to separate parallelism from choice and repetition. And these two views are both very useful. I'm constantly, when I do a process mining analysis, switching between the process map and the BPMN model. I find that they give you complementary perspective. One is a bit more complex, but gives you more information. One is a little bit simpler and is kind of quicker for doing filtering and abstraction. The second type of things that process mining tools give you are performance measurements. And they can do it in 3 different ways. One of them is by overlaying performance data on top of the process map or the BPMN model. And we have seen different types of overlays, frequency overlays and duration overlays. Bear in mind that process mining tools will usually even offer you more overlays, like cost overlays, how much every activity is costing, etc., etc. And in an overlay, the activities and the arcs are, in a duration overlay, the activities and the arc are overlaid with some statistics about their duration, the duration of the activity, and that could be the average, the mean, the sum, which is also called the total, etc. And the same thing for the arcs. The arcs contain information about waiting times, and the nodes contain information about processing times. So you get a very good picture of where your time is being spent in the process. The second type of visualization are process performance dashboards, and performance dashboards are very useful because they give you more of a bird's eye view of how different activities or different resources or any other attribute you have in your log, how the performance of your process is split across each of them, how frequent each activity is, how frequent every resource is involved, how much time every resource is spending in the process, or how much time each activity is consuming in the process. And the limitation of dashboards is like they convey more information in less visual space. The limitation is that they are not very good at conveying information about the sequence of activities there are. And that's why it's important to complement performance dashboards with performance enhanced process maps. We also saw that you can get a little bit more of a dynamic view on your performance of your process using animation. So you can discover a process model out of an event log and take one or more event logs and replay them against the model. And then you get some visualization, dynamic visualization of how the bottlenecks build up in your business process. So the third type of things you can do with process mining, apart from discovering the process and analyzing its performance, is analyzing whether or not the process is conforming to certain compliance rules. Like like for example, if you have a very specific way of doing the process, you can compare it against your actual process and get some insights into what the differences are. For example, you might find out that there are some activities that are being repeated in the process, in the actual event log, but according to the process model, they shouldn't be repeated. So that might be violating certain compliance rules that you have. Or you might find that after some activity, another activity needs to happen, but sometimes it's not happening. So that gives you some pointers to investigate deviations in your process with respect to compliance rules. We focused in this course more on what we call rule-based compliance checking, which is an approach where you try to capture your compliance regulations in the form of declarative rules of the form like, if this activity occurs, that activity should occur within 2 hours. And then we saw how you can use filters in a process mining tool, particularly path filters, to filter out, extract those cases that are violating a given compliance rule. And finally, the fourth thing that classical process mining gives you is the ability to compare multiple variants of your process. And a process variant is just like a subset of cases in your process. For example, if you have a process order to cash across all 3 Baltic countries because you have a company that is trans-Baltic, one variant of that process is the order to cash process in Estonia. Another variant is the order to cash process in Latvia. And another one is the order to cash in Lithuania. So every country is executing a variant of the process. It's like one particular way of doing the process. Naturally, they will deviate with each other because there are different teams performing this process. There are slightly different expectations from the customers in these 3 countries about how the process should be executed, slightly different demands. And at some point in time, you might want to compare it in order to find out why is it that in Latvia we are fulfilling our SLA, whereas in Estonia we are not? Is it because we lack resources? Is it because certain activities are not being executed in Latvia, but they are being executed very rigorously in Estonia, etc.? So you can use variant analysis to answer that kind of questions. And the standard technique is for these are to compare the process maps. So you filter out the log into the multiple variants using a filter. You save the 2 logs, and then you can open them in side by side in different browser windows and start comparing them. Or you can select both event logs and open them in a single performance dashboard. And that performance dashboard will compare along different perspectives the performance of your process in the 2 variants. So core process mining, just those 4 operations I summarized before, is a pretty widely used technique. There is a company that every year does like a survey of process mining case studies, and they have nice graphs about where it is used, in which countries, in which industries, for what purposes, what type of processes are being analyzed. And they have inventoried, found around 1,500 process mining use cases, a bit everywhere in the world, in manufacturing, banking, insurance, etc. And there is a very rapid acceleration in the past few years about the case studies where this is used, because organizations are realizing that they have a mine of data in their enterprise systems, and that process mining gives them a very quick way of using that data to analyze questions that they have always had about their business process. And just now, they can answer it using the data they have there. So, for example, personally, I have been involved in quite a few of those case studies. One of them with a Nordic financial company that does payment provider. It's a payment provider. When you swipe your credit card somewhere, chances are that that transaction is going through their systems, and they are doing like brokerage between, credit card companies and banks and end customers and merchants, etc. So somewhere in the middle in this payment systems provisioning, and they need to onboard customers, typically merchants, like your coffee shop next door, or a restaurant, or a hotel, or some store somewhere. And to onboard those customers, they have some onboarding process. They have to once they found potential customers, like all the lead management thing, they negotiate some contract terms, and they have to send them some hardware. They have to set up some things for them, and they have to train them, give them a little bit of training, and set up some paperwork as well on the back for compliance reasons and anti-money laundering purposes. And this process takes some time, more time in some cases than in others, more time in some countries than in others. A typical question that the customer excellence manager will have is, why is it that, say, in country X, we are performing much better in terms of this process than in country Y? Why is it that country X is doing differently than the other countries? How can we change the way we do things in the other countries according to that? And so they have data stored, say, in some CRM system like a SAP system, or in some ticket management system like ServiceNow, and they extract that data and they can load it into a tool, a process mining tool, and then they can start finding patterns that differentiate well-performing countries from not well-performing countries, or cases where we have not fulfilled some SLA between two milestones in the process, and cases where we have fulfilled that SLA. And that then allows them to identify areas of the process, particular actions that they can take to improve their process, and over time improve, for example, their customer conversion or their customer retention. So process mining, as we have seen it, kind of answers quite a lot of concerns, questions, problems that business managers have, particularly customer excellence managers or operational excellence managers. It is, however, a technology that is quite limited. So what we have seen in this course mainly is what I will call process mining 1.0, or descriptive process mining. Gartner has put forward this categorization of data analytics techniques into 4 categories. Nowadays, they have 5. Descriptive analytics relates to using data and hashing data, crunching data in order to describe your existing business situation, how you're currently doing, how your customers are responding to different types of campaigns in a purely descriptive manner. They try to answer descriptive and analytics techniques are any type of technique that tries to answer what questions. What is happening in my process, for example, will be a what question. What happens after we have sent a response to the customer? How much time it takes? How often do we get a response, etc. They are very descriptive questions. The next layer of analytics after descriptive analytics is diagnostic analytics. Diagnostic means that you not only answer questions of type what is happening, but also why is it happening. That's very important, because you not only want to know why is it, what is the conversion rate in my process between this point in the process and that point in the process, or between this point in the sales pipeline and that point in the sales pipeline. You, as a manager, you also want to know why is the conversion so low? What are the factors that determine whether or not a customer converts, accepts a loan offer, or rejects a loan offer? So diagnostic analytics is like any data analytics techniques, any way of crunching data to answer why questions, but in a tactical manner, meaning you look at the data post-mortem, you get some feedback, and you say, oh, this is why customers are leaving us. For example, it's because we are not delivering them their TV box in less than 2 weeks. and then they find some other provider somewhere else that delivers quicker. So that's the kind of questions that managers can answer using descriptive and diagnostic analytics. Now, the techniques we have seen up to now are descriptive and diagnostic. Mostly descriptive, a tiny bit diagnostic. Variant analysis techniques try to make some diagnosis of why something is happening. At least they try to find factors that affect that. The next layer in the Gardner classification of analytics techniques is predictive analytics. So any type of technique that is not trying to answer what has happened or why something has happened, but is trying to predict what is going to happen. So it looks into the future. Predictive process monitoring, which is one of the techniques we saw in some of the last lectures, some of the last lessons, is a predictive analytics technique. And the next layer above is prescriptive analytics. Prescriptive analytics is like predictive analytics, but it goes beyond. It not only tries to predict, but it tries to prescribe what should be done later at some point in time. One of the most mainstream technologies out there for prescriptive analytics are called recommender systems. And most of the large e-commerce companies, like for example, Booking.com or Uber or Bolt, etc., are using prescriptive analytics techniques. They try to find out what should we do at some point in time in order to improve some performance measure. So for example, if I am in the middle of a loan application handling process, what should I do in order to maximize for one given customer the chances that they accept a loan offer and they become our customers? What can I do? Should I send them another loan offer? Should I renegotiate the interest rate? Should I negotiate on the installments, etc.? So all that is prescriptive analytics. And the next step, which I do not show in the graph, is what is called augmented analytics, which is like prescriptive analytics, but instead of the machine prescribing what to do, the machine works with you to figure out what needs to be done next. Anyhow, coming back to our course, the 4 capabilities of process mining I presented and I recapped just now, they fall in the category of descriptive and to some extent diagnostic analytics. There is a whole bunch of emerging techniques in the field of process mining that I call process mining 2.0, just to give it a name, that try to work more on the diagnostic, predictive, and prescriptive side. Those techniques, which are still emerging and you will not necessarily find always out of the box in a tool, operate at 2 levels, at the operational level and at the tactical level. Every time you are doing an analytics project in a company, the first thing you need to understand is, are you doing something at the operational layer or at the tactical layer? We saw that when we discussed about performance dashboards. Operational layer means that your users are the people who are doing the work every day or their immediate supervisors. And what you are providing to them are decision support tools to take decisions on a day-to-day basis. Tactical analytics tools are tools that allow you to look at longer timeframes and that allow you to make recommendations for improving the way you do work on a long-term basis. And process mining 2.0 techniques can be found at both layers. I will briefly summarize some trends in the field of process mining, in the field of predictive process monitoring, prescriptive process monitoring, which are operational level techniques, and in the field of so-called robotic process mining and automated process improvement, which are tactical techniques. They operate at the tactical layer. Let me start with the operational ones, the techniques that try to use event logs to improve the day-to-day operations by providing decision support for daily decisions on the ground. One of them is predictive process monitoring, which we saw in this course. The purpose of it is to train some machine learning models on an event log of historical executions, grab that machine learning model, deploy it in an engine, and use that engine to generate predictions at runtime, so that if a case is ongoing, if there's a loan application of a particular customer in a particular state, the engine can tell you whether or not and with what probability that loan application will finish at the end. Will the customer convert? Will the customer accept the offer, or will they reject it? That's what these techniques are trying to predict. Or how much time there is until the end of the process, etc. The second type of technique, type of things that these things can predict, is what will happen next. What is the next event that will happen? What will be the following event after that? And how will the process unfold until the end? So we didn't see those kind of next event and remaining sequence prediction techniques, but they are out there. They use similar strategies than the ones you saw in this course, but they are often based on deep learning techniques, particularly deep learning networks with recurrent neural networks, which are techniques that are particularly suited for making predictions on sequential data, because they are always making a prediction and feeding back whether or not that prediction was correct in order to make subsequent predictions in the same sequence. So then they kind of have an advantage with respect to snapshot techniques, XGBoost-like techniques, that they make a prediction at some point in time and then they forget about it. You give them the next prediction task and they treat it as an independent task instead of linking it back to the predictions that it has done before. So predictive process monitoring techniques, to summarize, allow you to take data from a database, represented as an event log, train a machine learning model, then as new events keep coming in a streaming mode, it turns those events into predictions about what will happen at the end of the corresponding case. And those predictions can be then displayed in some sort of dashboard. So we have, myself been involved in projects where we build dashboards that allow, for example, an insurance claims handler manager to determine what will happen to a given claim. Will it be settled in less than 5 days, or will it require more than 5 days to be settled? And that kind of dashboards allows the operational manager to make resource allocation decisions, for example, to move people from one team to another in order to try to prevent certain violations of the service level agreement in a given side of the organization. So predictive process monitoring is a technology that is, I would say, transfer ready. Several companies are already using it. I know of several companies already using predictive process monitoring on a daily basis. The challenge of those early adopters of predictive process monitoring techniques are threefold. One of them is how to understand why the machine is making a given prediction, explaining the predictions, helping them understand the why behind the prediction. And there are some techniques in machine learning to do that. There has been quite a lot of progress in that field, both in terms of rule-based explanations, but also in terms of feature-level explanations. And many of you have heard, for example, about Lime or Shapley values, which allow you to understand what particular factors determine that you are making this particular prediction for this particular case in the process. So that is very good, but managers want a little bit more than explanations. They also want actions. They want to know not only that this customer will not accept the offer and it has to do with the interest rate that you are offering them. They would like to know, okay, so by how much will I need to make the interest rate so that this customer will accept the offer? So will a reduction of 2 percentage points in the interest rate convert these customers or not? So they want not only explanations, but they also want recommendations on what they should do to enhance the probability that a customer will accept the offer. Not only that, managers not only want recommendations, because that you recommend me to reduce the interest rate, okay, sure, but I'm losing money by doing that. So how can I do this, like make discounts on the interest rate that I offer to the customers, but in such a way that I maximize my profit? So like profit-driven recommendations. So you can define like what is the profit of a loan, or including the with respect to some risk factor, for example. And I would like you to make the recommendations that if I follow them in the long run will maximize the profit of the lending unit of the bank. So that's what they want. And that is where the state-of-the-art in machine learning is moving into. So it's a field that I call prescriptive process monitoring. Prescriptive process monitoring starts with building predictive models from an event log of completed traces, using that predictive model to generate predictions that, for example, a given loan will be rejected by the customer, and then feeding those predictions into a recommender system, which, given some knowledge about the cost structure of the bank, the profit that the bank makes on a loan, et cetera, will determine what is the best course of action to take based on historical data. How should discounts, for example, be made to customers in such a way as to maximize the profit? So they are generating recommendations of what to do next, like warnings, yeah, this customer will reject their offer, but also recommendations on how to prevent that, but in such a way that it maximizes the long-term profit of the organization. But this, in the field of e-commerce, is not science fiction. Companies like Booking.com, for example, or Airbnb are using this type of engines to try to, or even airlines are using this type of engines to try to optimize the fill rate of airplanes or of different types of accommodations in different areas, but in such a way that they also maximize the overall profit that they obtain from the reservations that customers are making of their services. But bringing that into the field of business processes with long-running, multiple steps, etc., is still a field that is evolving as we speak. And it's not only a technical challenge, it's a social technical challenge, because you have to not only provide techniques that make recommendations that are supposedly optimal, but you have to present them in a way that the managers will be able to implement them, given all the other considerations that they have in the organizations, because decision-making in organizations is highly multidimensional. Prescriptive process monitoring is something that happens at the operational level. It's like looking at the data on a daily basis and making recommendations about what to do next for a particular instance of the process. The next step in the field of in the field of process mining, in my opinion, is what I call automated process improvement. It's a tactical level tool or type of tool that, given some historical data about the event log, like an event log or multiple event logs, and given some domain knowledge from experts, for example, cost models, how much it costs us to do this, how much do we gain from doing this, etc. So given that information, they construct some recommendations for improving the way the process is being performed. It's like process mining, you see, but in process mining, you have to manually see, oh, here I have a bottleneck, and maybe the bottleneck is coming from the high workload of this resource or that resource. So maybe I should try to relocate one resource from here to there or from there to here to try to improve the process. But all of these, you are doing it manually. The idea of automated process improvement is that we can scour the data, given enough data out there, we can scour the data to find those improvement ideas automatically from the trends that are observed or the patterns that are observed in the data. And what type of improvements do we want to find? Let's take this simplified view of a loan application handling process I'm showing you here, right? This is very highly simplified. Loans arrive and they have to be checked. Then based on the information gathered during the verification phase, an assessment is made and a decision is made of whether to grant the loan to the customer or to reject it. And then there might be some back and forth after that. Given this process and given an event log of this process, I would like a machine to be able to find patterns that can serve to make recommendations for accelerating the process, making it more efficient, or improving quality by reducing defect rates. One of the type of recommendations that such a machine could generate would be, for example, that for consumer loans, it turns out that checking for the credit history, so checking the income sources before checking the credit history works better for consumer loans than doing it the other way around. In other words, you shouldn't check the credit history and then the income sources. If it's a consumer loan, do the income sources first. Why? Because after the income source, you might find out that the credit history check is not needed. The income of the customer is insufficient to give a loan at this stage. And then you have to go back to the customer and renegotiate the loan amount, because no matter what the credit risk is, their income sources are insufficiently documented for a loan of the size they are requesting. But I would like to find these patterns straight from the data. I would like also to find patterns like, for example, credit history check is actually skipped for all cases where the customer has requested a loan in the past 3 months, because then we have already a credit history already recorded in the database and we can reuse it. So obviously this is common sense, but I would like it to find it from the data. Yeah, always when this condition is true, you can skip the credit history check. Or if the credit rating of the customer is C or D on a scale of A to E, you should just not allow the customer to appeal the loan decision. So if we reject the loan decision and their loan rating is C or D, just reject it. Don't come back and start reassessing, because you will always reach the same conclusion given the low rating of the customer. That's another kind of pattern I can usually find in the data itself, and I would like to find it in order to make this refinement in the way I do the process. More interesting is you see how the workload in a process varies depending on the day of the week. So on Mondays and Tuesdays, we might have more workload in one area. On Thursday and Fridays, we have workload in some other areas. I would like a machine that can analyze the event log and tell me that reallocating resources to a given task on Monday and Tuesday will accelerate my process, and then reallocating some more resource to another task on Thursday and Fridays will accelerate it further, so that I can reduce the cycle times by refining the way I am using the resources throughout the week. This is actually like dynamic reallocation is something that is very often done in very large organizations like at Amazon warehouses, or if you look at Starbucks, their roster is managed in order to optimize resources, to put the resource at exactly the right moment in time during the day, so that they can have as high of a resource utilization as possible while maintaining reasonable waiting times for their customers, so the customers are not queuing up and leaving the coffee shop because they waited for more than 10 minutes to get a coffee. So we would like to bring that into the field of process improvement. Or finally, and this is a bit far-fetched, that you can analyze data and say like, hey, here is an activity that can be performed automatically in 50% of cases. There are 50% of cases where it needs to be done manually, but in 50% of cases, this activity is purely mechanical, clerical, and can be done automatically by a soft bot. So that's another challenging thing. So in essence, what we want, and that's what automated process improvement tries to bring into the table, and this, bear in mind, this is an evolving technology, still at the level of prototypes and pilots, use pilot cases. What we want is that given execution data, we can, one, identify tasks or parts of tasks that can be automated. That is called robotic process mining, because you are trying to mine or discover parts of the process that can be performed robotically by a soft bot, and therefore do not need to have human intervention. And from there, you want to derive executable scripts that you can put into a bot and do the mechanical parts of the task themselves, instead of people copy pasting and moving data around, be able to find that part of the task that can be automated. That's called robotic process mining. You will then like to look at the data in the event log hard and automatically identify opportunities for improving the order in which activities are being executed in the process. For example, you might find out that it's better to do task A before task B for some types of customers, because if you do it this way, you get lower cycle times or lower defect rates, lower customer complaints, etc. Or you want to say, well, currently, all purchase orders from a given region are being routed to a given call center. But we observe that actually call centers from that region that are, when they are routed to another call center, they are better resolved. So maybe we should be changing our routing rules, and instead of routing primarily that kind of customers to call center A, we should be routing them to call center B. These type of techniques are being used a lot, particularly in call centers, so that where there are routing decisions about how different calls should be routed, that find the optimal decision rules to route different cases to different parts of the organization, to different teams. The same in the context of an IT help desk. You kind of always want to find the optimal person to which you would like to route a particular case. And finally, resource optimization, which is about optimizing the number of resources or the times when your resources are available, the times of the weeks when they work, or the days, the hours of the day when they work, in order to have as high as possible of a resource utilization, so very high efficiency, but also in a way that does not affect the waiting times or the cycle times of your process, and therefore does not affect the customer experience. Let me show you some, just to give you an idea. I will zoom a tiny bit into two of these boxes I just showed you to see what are the techniques that can be deployed in each of these cases. So the first thing you want to do with an event log to do automated process improvement is to identify opportunities for automation. This is a holy grail. If you can find opportunities for automation and you can accelerate the automation of these tasks, then you will gain like immediate benefit efficiency gains, because you will be able to scale up more and do more work with less resources. And the challenge here is, imagine I can record everything that is happening in a process down to the level of how the workers are using the enterprise system or the different applications that they use for business purposes, so that I can later identify what tasks that they are performing could be partially or perhaps totally automated. So I have event logs that record either activities, but maybe more fine-grained, they record specific steps, clicks, field edits, etc., that you are doing on the user interface of a system. and you want to find out if parts of these tasks that people are performing on a daily basis can be automated, and if so, how they can be automated. There is a particular type of technology out there which is very, very widely used nowadays, which is called robotic process automations. It's kind of tools that are like, they have a recorder where you can record how to do one task. You know, for example, taking data from an Excel spreadsheet into a subsystem or an Oracle system. So you take that and then you teach the bot how to do a task, and then the bot then starts doing that task every time that a particular type of email arrives in a mailbox with a certain type of attachment. It grabs it and enters that data into the enterprise system or into the CRM system, etc. So, the bots effectively what they do is that they take as input scripts with specific steps that need to be done on different applications, and then they execute it. And they can do stuff on pretty much any application you can think of. Adobe Acrobat, Word, Excel, Office, your favorite email client, browsers, different types of applications on browsers, etc. So they can repeat. It's like if you write a script, they can just go and repeat it and perform automated tasks. The question is, which task can be automated? What makes it that a task can be automated? And one of the key to the answer is that a task can be automated if, imagine a task consists of 10 steps. Like you copy here, you edit a field there, you copy another thing there, you type something here. If at every step I can determine what data I will put into the system based on data that I have seen before in previous steps, and at the next step, it's again the case that I know what I'm going to do based on data that I have seen before in the task or in previous tasks. If you are in that situation where every step, all the data that is needed to perform the step has been seen before, then that task is essentially automatable, because then a bot can then retrieve that data, put it here, move to the next task, retrieve data, put it there, move to the test task, etc. So the problem of robotic process mining is about finding tasks that we call automatable tasks that from a user interface log, from a log where the events represent specific interactions of a user with an application, find if there are any tasks that are automatable in the sense that every step in the task, all the time, the next step can be predicted deterministically, and the data that is used in the next step can be computed from data seen in previous steps. And for that, there are certain techniques for doing that. One of them is embedded in a prototype called Robidium, and it takes as input a user interface log. It simplifies it. It finds the different, it segments it into pieces using typical sequence mining techniques. And then it finds sequences of tasks that get repeated very often. So for example, we see that copy from here, paste there, edit this field is a task that is very often repeated. And then what it does is that these are called candidate routines, and it tries to find for each such candidate routine if the data needed in every step can be retrieved from the data seen in previous steps. And this problem of finding whether the data I need in this step can be retrieved from data in previous step, that is called, it's a data transformation discovery problem. You want to know how to transform the data you have seen into the data that you need now. Can you automatically compute the data that you need to enter now into the system based on the data that you have seen? If the answer is yes, then you are able to generate a script to do that data transformation from data you have seen to data you need to enter into a system at a particular step. And that is essentially the way it does it is by treating everything as a data transformation problem. It looks at the state before a task is performed, the state after it is performed, and possibly some intermediate steps. And it tries to find if there is a way that we can compute all the data that we enter into the system from data that we have read out of a system. So it looks at all the data that is read during the execution of the task, all the data that is entered or written during the execution of the task, and it tries to find the mapping from the data that is read to the data that is written. And if it finds it, it will say, yes, this sequence of steps is automatable, and here is how you can automate it, because it becomes purely a problem of computing a transformation from the data you read from a system to the data you write into another system. So for example, if you have in an admissions process, for example, you have a lot of different types of documents coming in, PDF documents that are put into on OCR thing and extract different tables, data extracted from different systems, some of which is being manipulated into Excel spreadsheets for the purposes of ranking the applicants for a given master's program, for example. There is a lot of emails with the students with various documents attached. So if you can analyze what the workers in the admissions office are doing, what is coming in the spreadsheet in the attachment, what they are doing with that spreadsheet, how they are entering data from a spreadsheet they receive by email into the admission information system that they are using. And you give that recording, let's say you record like 4 hours of an admission officer working with transferring data from emails they receive from students into the admission system, or using data in the admission system to send an email to the student, you will notice that there are some patterns. And using sequence mining techniques, you can find those repetitive sequence of steps, and using data transformation discovery techniques, you can determine which of these sequences of steps, called routines, can be automated because they merely involved reading data from somewhere and writing data somewhere else. And we did a pilot at the University of Melbourne with the admissions office, and by recording 90 minutes of 2 different workers, we're able to identify 5 automatable routines that for which one could produce scripts that can be executed in a robotic process mining platform to execute those routines that these workers are doing. And in that way, you can automate the routine part of their work and supposedly allow them to focus on their non-routine work, the part of their work where they need to take decisions, for example, on how to formulate an answer to a question from a student. And there's a lot of developments in this field of automated process improvement. I made a mistake. One of them is called search-based optimization. And search-based optimization kind of works as follows. From the event log from an event log, you can discover a simulation model. And in fact, in homework 3 of this course, I asked you to do exactly that. I gave you an event log. I discovered a process model myself by using a Promore, got a BPMN model, and I asked you to discover a simulation model out of it. And you did it manually, but that can be done quite automatically, because actually all the data about distributions of processing times, number of resources available who perform a task, when do these resources are available or not, like their availability timetable, it's all in the data, in fact. So you can compute all the simulation parameters from the data, and there are techniques and tools for doing that. Given that I have a simulation model and a process model, I can start doing some tricks. Like I can start saying, what if we change the order in which the 2 tasks are performed? What if we add a resource to this task? Or what if I remove a resource to this task? What if I tell this resource to work on Monday, Tuesday, and Wednesdays on this task, and on Thursday and Fridays on these other tasks? I can think about a lot of changes, and then I can get a machine to perturb the process with all these possible changes and generate heaps of other candidate processes that we could have, like lots of possible to-be processes, and then use some search-based optimization techniques, like, for example, genetic algorithms, hill climbing, taboo search, simulated annealing, etc., to then try to find possible what-if process models. So what if we reallocate resources? What if we change the order to the tasks? Then I can use the simulation model I automatically discover from the data to evaluate how good all these alternative ways of performing the process are. And then I can feed that back into the optimization engine to determine what is the optimal way of doing it. So these are some of the developments that are going on in the field of process mining as we speak. And they are taking process mining in that direction of becoming a way of applying artificial intelligence for business process management. So the trend is to use more and more techniques that are classified as being in the realm of artificial intelligence. That could be natural language processing techniques, rule mining techniques to discover rules automatically from the event log, causal process mining techniques that tries to discover causal relations between doing something in the process and an outcome. For example, what is the causal relation between making 3 offers to the customer versus making 1, and whether or not the customer affects? By how much do I increase the probability that a customer accepts an offer from there, from making a second offer? So how valuable it is to make a second offer in terms of the conversion rate. So if you want to answer these questions, you should be looking into a type of technique called causal machine learning, particularly a type of technique called uplift modeling that allows you to estimate causal relations between a treatment, doing something, and an effect or an outcome, like customer converting or not converting. These are just some pointers to papers out there, all of them with Python code that give you different directions among those that I have mentioned before: automated process discovery, automated process improvement, causal machine learning, causal process mining, robotic process mining, all of them potential ideas for the freeform part of your project. And that is what I wanted to say for today. And basically with this, I close the course. As you have seen, process mining is both a relatively easy to use technique to analyze, to answer business questions about a business process using data coming from an enterprise system, but it's also a basis for applying different types of artificial intelligence techniques, optimization techniques, causal process mining techniques, predictive analytics techniques, like we do in predictive process monitoring, or prescriptive techniques to make recommendations. So it's a way of basically turning data into insights and insights into recommendations for actions. Well, thank you very much for staying until the end, and hope that you will have ample time to practice the techniques we have seen in the field of process mining in this course.